Hello. We will be doing a very important topic of this chapter, which is to derive an expression, okay, of potential of potential due to a point charge, due to a point charge. Okay, this is a important derivation for the exam point of view. Okay, like in the previous class we had defined what is potential, right? Potential, we said that it is denoted by V, and this is what it is: the work done in bringing any test charge from infinity to that point. I hope we will remember this definition. Okay, based on this definition, we will be going to derive the expression of potential due to a point charge. Okay, let's say here is a point charge and the field is due to the point charge. Okay, now let us find out, let's say at a finite distance of r, what will be the potential at this point. Okay, let's call this point as A. Okay, so in this section we will be going to we will be going to find the expression of potential at this point. Okay, now in this case, as it is evident from this expression, that potential is the work done in bringing test charge from infinity to that point. So at this, if we are interested to find the potential at this point, that means what? That point is what? That point is A. So here for this, in this case, the definition will turn out to be this one. Okay, so this is infinity A. All right. Okay, that means a test charge have been brought from infinity to this point. If we calculate the amount of work done divided by the test charge, then what we will get? The potential at this point. Okay, it looks simple, but one thing, okay, we know that work done, all right, work done work done is what? It is force dot displacement, right? Now as the test charge is being moved from infinity to some point, is the force is a constant force? No, right? The force is variable. As the test charge approaches nearer and nearer in the field of Q, then what? The force will keep on increasing, right? So this definition of work done is valid when the force is a constant force, but in this case the force is not a constant force, right? So if the force is not constant, then how to find out the work done? Then work done, give me a moment, work done in this infinity to this point A is given by, if the force is a variable force, then that is what? Infinity to A F dot dl. Okay, F dot dl means whenever we see the integration type of things, this is always true. Okay, if the force is a constant, then for all the distance s, the force will be the same. So F dot s, right? Now this dl is a very, very small length, and we assume that at this length, what to say, the force we assume to be a constant force. Okay, so let us take up 2 points. I'll call this point as point P and point Q. Okay, and we assume, okay, we assume that at this very small length dl, okay, the force has become constant. This is our assumption. Okay. So if the force is a constant, then what? The electric field will also be a constant, right? Because what? Force in an electric field is what? Due to the electric field, right? So the force on this Q0 is due to the electric field. So force is equal to Q0E. So at this distance, as we assume it's so small, force is constant means what? Electric field is also the constant. Okay. Now this same definition, there are small things, students, you need to know about this, is equal to integration of dw. Means what? While coming, let me remove it. While coming from infinity, we are assuming that Q0 is brought from infinity to this point. The small path work done, we are computing it, right? All the small paths, we are computing it till A, right? And dw is one of that path. Okay, one path will take and will integrate from where? From infinity to A. All right, and it carries the same meaning. Okay, infinity to A. Now F is what, student? Okay, this force, now this force is against the electric field. Okay, see, I'll make this figure again. Okay, because everything, all our derivation will be based on this figure, and this figure is an extreme important one. So let me make it again. The notes, on the notes everything will be written, so I'm not writing it. Okay, I'll make it in a better way. So this is infinity. Q0 have been moved from infinity. This is in the field of Q. Let's say this is a point A. This point A is at the distance of, we called it at the distance of, all the measurement is made from O. This distance is RA. Okay, then we had considered a small length PQ, and the length of PQ is such that the length of PQ, we took it as DL. Okay, this distance have been taken as DL, right? Now Q0 at this point, the force experienced by Q0 is equal to what? Q0E, right? And what is the direction of the force experience? Q0 will experience what? A repulsive force, but it is brought against that repulsive force. Now in order to move this direction, what should be the applied force? Applied force should be what? Applied force should be minus of it. Exactly, just in order to move, right? So this force, okay, this force is against the repulsive force, right? So minimum amount repulsive force. See, there are some of the assumptions, like we assume that the kinetic energy didn't increase when it is brought. Okay, so the whole of the energy is potential. That is why, what to say, at this point, in order to bring this process very slowly, okay, then what is the minimum amount of applied force in order to move this way? I'm repeating, that should be what? F is equal to minus Q0E, right? Okay, then in this, all right, then this is the same, right? F dot dl, right? Now what is this F? F is minus Q0E. Then W infinity A, this is equal to what? Okay, we'll keep on doing it. Minus Q0 E dot dl, right? Okay, E dot dl. Now whenever there is a dot product, this is what it implies: the cos of the angle between electric field and dl, right? Isn't it? Now what is the angle between electric field and dl? Okay, q, this minus q0, all right, it is a constant, so we can take it out from the integration, and this infinity A, it remain as E dot of dl, right? Okay, what is the angle between electric field and dl? Now can anyone say what is the direction of dl? See, as I have said, O is the origin, right? Then all the measurement along this side is taken as positive, right? Now when it is moving from P to Q along here, right? So what is the direction of dl? The direction of dl is along this one, right or not? Okay, dl is brought this way. Which direction we are supposed to take? Opposite direction is positive, right? So the direction of electric field, so what we will do, dl, the direction of dl is along here. So we are going to assign, there are small things in this derivation, which is the minute things you have to consider. As it is brought this way, and this is opposite to the vector which is taken from this origin, right? So what we are going to take, we are going to take dl equal to minus dr equal, okay, it simply means positive of it. Okay, so infinity A minus E0 infinity to A, okay, E dl, okay, electric field is along this direction, dl is along this direction, so dl, right, what is the angle? This is 180 degree, so dot product it is, so it is dl cos of 180 degree, right? Cos of 180 degree is minus 1, I hope you know that. So this is if it is minus 1, then minus 1 into minus 1, minus into minus, this will be plus, so the whole thing will be what? Infinity to A E dl. But as I have said, this direction is negative direction, right? Because it is moving against the field, while all our measurement is along this side. So what we need to take, we will be taking dl equal, but in just to tell dl is opposite to it movement, so we will put the minus on it. All right, so this will be w infinity A q0, can I do this thing, infinity to A E minus of dr. You understand the logic behind it, right? Now what will be the electric field at this point? At the overall this distance, electric field is the same we considered, right? So electric field due to a point charge is what? 1 by 4 pi epsilon naught q by r square. This derivation we already did. Now what we will do, we are going to put the electric field expression and we are going to integrate it. Okay, so when we integrate it, after integration we will put in the definition of potential, then we will get the everything. All right, so q0, okay, electric field at pq is same. What is the expression? This is 1 by 4 pi epsilon q by r square, and this is minus is there dr. See why I have chosen dr in place of dl, because in our term there is r, so integration will become easier. Okay, so infinity A, this equal to, okay, 1 by 4 pi epsilon naught is a constant, q is a constant because the field or in the field of q, right? So all those things I can take it out, all the constants can be taken out, 4 pi epsilon naught, and this is equal to what? Infinity to a. Okay, infinity to, now the variable, the what is the variable, that only we need to integrate. Now what is the, as it is brought from infinity to this point, which is the variable, the distance will keep on getting smaller. So distance is the variable. So from infinity till where? To what distance? Till Ra. So the integration limit will also get changed. All right, dr by r square. Okay, students. Now, okay, let me rub it. Different texts have done differently. This derivation is little bit complex because you have to consider the minute things. Okay, so this will become what? W, I'll show you all the steps. Okay, I'm not going to skip anything. This by 4 pi epsilon naught. Okay, integration of x to power n dx is what? X to power n plus 1 by n plus 1, right? Now in this case, what is the integration of it? Integration to r to a. Now what I can write this one? R to power minus 2 dr, right? So in place of n, what is there? Minus 2, right? So infinity a. Now I will integrate it in this 4 pi epsilon naught. Okay, now if we integrate it, n plus 1, right? So r to power minus 2 plus 1 by minus 2 plus 1, right? Here the limits are fixed, so we are just going to put the limits. Then you need to put the limits on the variable, right? So minus 2 plus 1 is minus 1, minus 1, minus, plus it will be, right? Or we can say they will cancel out each other. So this will be what? Q0 Q by 4 pi epsilon naught. Then r to power minus 2 plus 1. That is what? R to power minus 1. R to power minus 1 is what? Yes or no? Okay, limits. Now, where you have to put the limits? On the variable. How? Upper limit minus lower limit, right? So if you do it, upper limit Q0 Q 4 pi epsilon, upper limit is what? 1 by Ra, because you need to put the limits on the variable only, minus, what is the lower limit? Anything divided by infinity is what? 0. So this term will be what? 0, right? Okay, then we have come to the end of this derivation. Then this will be what? This is Q0 Q by 4 pi epsilon naught Ra. This is the expression of work done. Then what is potential? We are supposed to find the potential at A, right? What is the definition of the potential? Amount of work done in bringing the discharge, right? Then what is the amount of work done? The amount of work done is 4 pi epsilon Ra divided by Q0 is what? 1 by Q0. Then what we get? The expression of potential is 1 by 4 pi epsilon naught Q by Ra, right? This is the expression of potential, or the same thing we can write. 1 by 4 pi epsilon is a constant, right? So K Q by the distance where we want to find the potential. All right, now let me sum up one thing. Okay, see, so up to here, I hope you if you see the video properly, you will be clear about it. See one thing, when it comes about the Coulomb force, what was the Coulomb force? 1 by 4 pi epsilon. Okay, that is K. Let me write it just. About the Coulomb force, this is K depending upon the two charges, attractive and square of the distance, right? Then in order to explain the Coulomb force, we have built up a concept of the field, and due to a point charge, what is the expression of the electric field? The one who is producing the R square, right? Okay, now in order to explain what to say, in the field we have got one more concept, which is a potential. And what is that potential? Potential is kq by r. Okay, so in electric field there is square, in potential there is only r. Okay, so I think this way you can memorize it also. Then one more thing, remember potential, the real definition of potential is this. All right, for a point charge the outcome is this. Okay, now as potential is the work done, is the measure of work done, and work done is a scalar quantity. So remember, potential is a scalar quantity. Okay, it's a scalar. So doing the mathematics with the potential, it becomes very easy, as it is not a vector quantity. Thank you.